All that weight of a big heavy building rests on the bottom column. Here's the column. And that column rests on a base plate, and that base plate then rests on the foundation. And so the base plate spreads the load out over a bigger area. And notice you can see the weld beads here. The column gets welded to the base plate. Here are a couple of base plate details. AISC says if the base plate is thicker than 4 inches thick, you're required to machine it where the column will sit on the plate. You don't have to machine the underneath surface where it's going to sit on some of that grout stuff, but the top you do need to machine. You can read about that in the AISC Steel Construction Manual. That grout stuff is it's a non-compressible, kind of like, think of like mortar, heavy-duty mortar. And so it goes under the base plate. In some cases, you'll leave a space here, and the contractor will use these leveling jacks to level out the base plate and then pour the grout in. For small columns, the fabrication shop welds the base plate onto the column in the shop, and then that whole thing, the column and base plate, is shipped as an assembly. But big base plates can be really heavy, like if you had a base plate that was 8 inches thick and 36 by 36, that weighs a little over 2,940 pounds for that one piece of that one plate. So you're not lifting that up by hand. So you need a crane for that 2,940 pounds. Also, to level this thing and get the grout under it, that's really heavy to be leveling. So they'll use a thinner leveling plate. They'll get that leveled and put the grout under, and then they set the gigantic base plate on top of the leveling plate. Here's some more about that. Moment is the tendency of a force to cause rotation. It's like torque. In a tall building, the wind blowing on the tops of these columns can cause rotation down here at the bottom of the column, so the engineer will specify these moment resisting connections. Here are some with some angle irons, some angle clips, and these angle clips do not actually have to touch. In fact, they don't touch so that water can drain out, but they prevent the column here from swinging around and rotating too much. So at the fabrication shop, you'll have a column base plate detail that will call out all the sizes of everything. There's another one. In a really big building that's really heavy, or depending on soil conditions, you might need this, an engineer will specify this column grillage, which is bigger than a base plate. It's got beams at right angles to each other in kind of a sandwich stack, and it spreads out the load over a big area. What holds the base plate to the foundation is a thing called an anchor bolt. And the anchor bolt, there are 4 of them on every base plate. It's typical to have these, I don't know what you call them, J-bolt, an anchor bolt with a hook on it. This page is out of the AISC Steel Construction Manual, and it's talking about sizes of holes. AISC says for ordinary bolting of stuff, the hole should be 1/16 of an inch bigger than the bolt that goes through it. So if you're using a standard 1/2 inch bolt, the hole will be 9/16, 1/16 of an inch bigger. Well, in base plates, just imagine trying to wrestle all these parts into place, and they're really heavy. the holes are more oversized. So for example, I don't know if you'd ever have a 1/2-inch anchor bolt, but let's say you did, then the hole would be 1/8 of an inch oversized, so a 5/8 hole. If you had a 1-inch diameter bolt, more likely, then if you were using a 1-inch diameter bolt and it was not a base plate, a 1/16 of an inch oversized hole would be 1 1/16. In a base plate, where you want a bigger clearance, a bigger hole, that hole would be 1 1/4 inches to accommodate a 1-inch bolt. The fabrication shop, or the drafter at the fabrication shop, will draw anchor bolt plans that show where the anchor bolts go and what size they are. And of course this is important because when the concrete gets poured for the foundation, these anchor bolts get set at that time, and so it's critical that we know just where they are located. Here's another better looking example of an anchor bolt plan, and notice we can see these big beefy outlines of the columns with the 4 anchor bolts around each one. And one more anchor bolt plan, and a little bit more detail.